Hello, in this video I'm going to show you how to draw the Lewis dot structure for chlorine trifluoride. First we're going to write down the two different types of atoms that we have. Then we will write down their electron configurations. Chlorine's going to have a neon core, 3s2, 3p5, and fluorine is going to have a helium core, 2s2, 2p5. We can get the valence electrons for these guys by summing together these superscripts. So this guy's going to give me 7 valence electrons, and this guy is also going to give me 7 valence electrons. Now we can figure out the total number of valence electrons that we have to work with. We have 1 chlorine that's giving me 7 electrons, plus 3 fluorines giving me 7 electrons, for a total of 28 electrons. Now we need to decide who's going to go in the center. We want to put the less electronegative atom in the center. Fluorine is the most electronegative atom, so chlorine has to go in the center. Now chlorine's a very electronegative atom. We normally wouldn't put it in the center except for when it's paired with something like fluorine. We're going to put our fluorines in a little spoked wheel around the chlorines. We had 28 electrons to work with. We just formed 3 bonds. Each of those 3 bonds required 2 electrons, so we burnt 6 bonds. We have 22 electrons left to work with. Now I can add up to 6 dots, 6 electrons, 3 lone pairs to each of these fluorines before they get their octet. So that's what I'm going to do. We had 22 electrons in our bank. We just burned 3 times 6, 18 electrons, placing those dots. We now have 4 electrons left over. 2 lone pairs, those are going to have to go on chlorine in the center here. And now we do our count. Fluorine, 1, 2, 3, 4, 5, 6, 7, 8. All the other fluorines are the same way, so they all have their octet. This chlorine, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I mean, that's too many, right? So this is what we would consider a hypervalent compound. The chlorine is being forced to have a valence higher than 8 in this scenario. And if we pay attention, what really happened here? I mean, we had too many electrons to place in this case. We may just have too many atoms to place on the central atom. These are the 2 things that are going to kind of indicate to us that we have hypervalence. The important thing is that we're going to expand the valence of our central atom. We're not going to do that with the terminal atoms. So the extra electrons that needed to be placed needed to go on chlorine in this case.